Welcome to Google Cloud On Air, live webinars from Google Cloud. We are hosting webinars daily, and you are watching the Dev Community, a show where Google Cloud experts from the developer community share perspectives about the cloud ecosystem and what's trending. My name is Nathan Harvey, and I'm a developer advocate with Google Cloud.
Hi, I'm Nicole Forsgren, and I am the DORA lead. And today we are talking about the Accelerate 2019 State of DevOps report. So let's get started.
Yeah, let's. So the Accelerate State of DevOps report, it's all about how do you become an elite DevOps organization.
Absolutely.
So what we're going to talk about today is this. First, DevOps is here to stay. Next, we'll look at some of the 2019 benchmarks. We'll talk about how to improve, what works and what doesn't when it comes to scaling, and then we'll leave you with a few takeaways and probably a reading list. So first, DevOps. What is DevOps? Well, DevOps is a cultural and technical movement focused on delivering value by simultaneously improving velocity and stability. DevOps encourages cross-team collaboration, shared incentives and responsibilities, and an environment that celebrates learning.
That's kind of a lot to decompose, so
yeah,
there's a lot to get into. So don't worry, we're going to be talking about some of that today. The thing that I love talking about when we say that it's here to stay is that it has really crossed the chasm. So what we found this year is we've really kind of validated what so many analysts have been talking about. For anyone who dug into the 2018 report, we found that 17% of the respondents were elite performers. But if you take a look at this chart here, that's kind of a subset of the high performers. Here's what we found. That subgroup broke out into their own group. It's 20% of our respondents this year. So that's pretty significant, right? They almost tripled. It really has crossed the chasm. We also see 23% of our group is high performers, 44% now are medium performers, and 12% are low performers. Now, for any of you who are kind of mapping this across, here's what we see. As I mentioned, elite performers have almost tripled. That high performance group has pulled across. Now, medium performers grew. Where did that growth come from?
Yeah.
Low performers shrunk, so many of them got better, grew into high performers. Some of our high performers fell back into medium performers.
Nicole, why is that?
So we have a few theories. In many of the organizations I've worked with, what happens is some of them are struggling with complexity. A few of them also are sitting back.
Well, sure, you said DevOps has crossed the chasm, so I've made it. I'm DevOps now. I can stop. That was quite a journey, but now we've reached the destination.
Exactly, and that's not the way continuous improvement works. You don't just get to do a maturity model, check it off your box, and be done. We need to keep improving, particularly when we work in things like technology, where it's highly complex.
So this is also interesting. You mentioned that the elite performers have broken out. So help me understand a little bit more about what does that mean from 2018 and as we move into 2019?
I love that question. So how do we even measure this? Let's talk about this. So when we talk about DevOps and performance, it's important that we're all speaking the same language. So when I'm doing research, it means measurement. So some of you may have heard of 4 key metrics. This has become an industry standard. These are the 4 key metrics. We're talking about speed and stability. The speed metrics are deployment frequency, how often you're pushing code, lead time for changes, how long it takes to go from code commit to code running in production, and then 2 stability metrics, time to restore service, how long it takes code to come back up, and change fail rate.
Okay, so first, time to restore service. That's like when there's an incident or an outage or something like that?
Exactly.
Some sort of service disruption. How long does it take us to get back to that?
Yep.
Okay, that makes sense. And then change fail rate. I mean, I understand each of those three words on their own, but putting them together, I don't understand what you mean there.
Exactly, and I'm glad you asked that question. So change fail rate, and by the way, you can dig into the report. We have lots of words there. But basically, it's the percentage of changes that fail, but it's not just an epic failure. It's not when your systems come all the way down. It's any type of code that you push into production that requires any type of attention. So if it's any type of instability, any type of incident, and it's a percentage. Right?
Gotcha. So it doesn't necessarily mean that we had to roll it back, but it does mean that some human had to take action on that after the change landed.
Exactly.
All right.
Now, the really interesting thing and the really important thing to note is that for 6 years in a row now, we've seen that speed and stability, all four of these metrics, go together. They move in tandem. They cluster. So that picture that you just saw, that comes from a cluster analysis. So statistically, well, technical term, I take them all, these four metrics, I throw them in the hopper, and I see what happens, how they group. And we have always seen that these four group together. In the past, it's been into 3 groups. This year, it fell into 4 groups.
Okay.
Elite performers, statistically, those 4 group together, and then we have kind of a gap. And then the 4 group together, and then we have a gap, and then the 4 group together and a gap. And that's why we call them different performance profiles.
I see.
Elite, high, medium, and low. So the faster you develop code, the better stability is, the higher reliability you also have. Which I think is...
Nicole, so I get the clustering here, but
Yep.
do you mean the elite performers are fast, or do you mean that the elite performers are stable?
They're both. You don't have to sacrifice speed for stability or stability for speed. Now, here's why. When we think about this, if we're pushing code more often, we're pushing it in smaller batches, which means that when our code hits production, it's smaller. Let's think about that in reverse. If I push code less often, it batches up, so I have a bigger chunk of code. So I have a bigger chunk of code hitting production, which is a larger blast radius, which means it has a higher likelihood of causing an incident. And when I do have an incident, it takes longer to bring my code base back up, and it takes me longer to fix because it's harder for me to debug.
I see. So to be more stable, we have to move faster. And to be faster, we have to be more stable?
Yep.
And those things move together.
And they move together.
Oh, no, that's really interesting. But how do you really find those elite performers within that cluster?
With those 4 numbers.
I see.
And I do that statistically with, it's math.
Math.
That cluster analysis, math and stats. Now, what does that look like though? So often people want to take a look and understand where they are. So this is our benchmark. And as I mentioned, elite performers are optimizing on all 4 measures. So we can see the elite performers are pushing code multiple times a day or on demand. The lead time for changes is less than a day. They can get that code all the way through the pipeline. Time to restore service is less than an hour, and change fail rate is between 0 and 15%. It's usually closer to 2 to 3 to 4 to 5%. Now, low performers, in contrast, the deployment frequency is between once per month and once every 6 months. Lead time for changes is between 1 month and 6 months. Time to restore service is between 1 week and 1 month. And that change fail rate, take a look, between 46 and 60%.
So that's about half the time I have to intervene after I've pushed a change out into production.
So think about that. So much of your time is spent debugging your own code in production, putting out fires.
Is that usually planned for?
Probably not.
Right.
So think about value creation, whether it's in features or building out new infrastructure.
Right.
This is the value of DevOps.
Yeah, and you know, when you talk about deployment frequency, and especially looking at that elite performers, you say multiple deploys per day. So what if I'm not doing multiple deploys per day? Does that mean I can't be an elite performer?
So what it means is you probably aren't. And we should be pushing towards that. Now, it does say on demand and multiple deploys per day. On demand is important there because it's the difference between a business decision and a technical constraint. So if you can, but you're just not, we do see some differences between, in retail, you may push to a pre-prod environment, but you aren't necessarily pushing to like an app in the App Store because like no users want to be refreshing their apps every single hour.
Right. Okay.
But again, it's a business decision and not a technical constraint.
I see. Gotcha.
And it's important because it's not just for features, it can be for compliance and regulatory changes. It can be for patches. It can be for security. It enables so many things.
Nice.
Okay, let's move on. There's
Yeah.
so much to cover.
Yeah. So what do these numbers actually look like when we put them all together?
When we put them together and when we compare, we see that our highest performers, when we compare to our lowest performers, see 208 times more frequent code deployments, 106 times faster lead time from commit to deploy. Now, what does that enable? Like I said, it's not just features, it's stability, it's reliability, it's security. So it's over 2,600 times faster recovery from incidents.
Wow.
It enables stability. It's 7 times lower change fail rate.
I mean, these numbers are almost hard to believe.
I know, right? But we've seen it several years in a row now.
How long has this report been running?
6.
This is the 6th year.
This is the 6th
and
year
the
now.
numbers, it sounds like they're probably improving over time, but they lay out essentially the same.
Yep, exactly.
That's incredible. Now, it's great that you can recover fast and that your change fail rate is low and you're deploying fast, but what about availability?
Availability is super important, and I'm glad you brought this up because there's this saying that I love that day 1 is short and day 2 is long.
Mm-hmm.
And for those of you unfamiliar with it, it's that we can build code, we can make software relatively quickly, but we need to maintain it for a really, really long time. And that's what availability gets at. It's about the assertions and the promises that we make and keep to our customers. And so availability is important. We started researching and measuring availability and its impacts last year in 2018. We measured it again this year and found that, no surprise, it's really important. And it's important for a couple of reasons. In part, it helps us predict organizational performance better than software delivery alone. Now, organizational performance is important from a commercial standpoint and a non-commercial standpoint. Everyone's like, Nicole, what? Girl. That's my academic hat on. Commercial are things like productivity, revenue, right?
Yeah.
Non-commercial are things like effectiveness and efficiency and customer satisfaction. So it just comes back to delivering value.
Okay, great. So how do we think about availability? This is a good question.
Yeah, this is a great question. And availability is, again, about that long tail. And so I really like to point people to Google's SRE practices.
Oh, and this is something that I definitely know about.
Yes.
So Google's SRE practices can really help define availability. And the thing that I love about the SRE practices when we talk about them is it always starts with the customer. So we're really thinking about what does the customer journey look like? What is the customer expecting? Availability, if your server's running but your customer can't complete the task that they wanted, is your service really available? Probably not. So it all comes down to that customer-oriented focus. We want to understand what are our customers trying to do with our services. And to that end, the SRE practices also introduce these 3 different dynamics or dimensions that you can look at. The service level indicators, service level objectives, and service level agreements or SLAs. So let's just walk through them, and I'm going to sort of count down in reverse. So we'll go 3, 2, 1. We're going to start with service level indicators. So a service level indicator is an indicator that your service gives that says, hey, are your customers happy or are your customers sad? It's a good way to sort of measure uptime, availability, latency, things like this, things that matter to customers. And then an objective, a service level objective, is a goal that we set around that metric. So we want to make sure that we're available N% of the time. Maybe that's 99.9% of the time. And maybe our latency, our service is responding fast, right, when we expect it to. And then a service level agreement kind of goes a step beyond that. Now, a service level agreement is typically an arrangement that is made between businesses. And so when you miss your service level agreement, there are usually consequences. Those consequences usually are a refund to your customer. And I don't really know what business you're in, but I bet it's not giving your customers money.
Probably not.
Yeah, probably not. We want to take the money from the customers. I mean, we want to earn that money, obviously.
And we want to make our customers happy.
Absolutely. And so when we look at service level objectives and service level indicators, it's really about what makes that customer happy.
Absolutely. Okay, now, this is some fun stats. This is some stats nerd time.
Yeah.
But I love this because it's really, really interesting from a practitioner point of view, from an executive point of view, from an industry point of view. So this year we ran additional analysis. Well, for the last few years we've run additional analyses. And for years we found that industry doesn't matter, right? If anyone's ever heard me talk, I always say industry doesn't matter. guess what? For the first time, industry matters.
Okay, so first, industry doesn't matter. Now industry does
matters.
And
now,
so what you mean is that industry can help us understand if this organization is going to be an elite performer or a low performer?
Or if industry may have an impact.
I see. Okay.
Right? So for an example, for years, people have always said, oh, but I'm highly regulated.
Right.
Right? And I've always said,
doesn't matter.
Don't make excuses.
Okay.
I mean, I love you. Also, don't make excuses. So we capture industry for a dozen industries. This is just kind of a representative sample. What we have found...
Let me guess. My guess is that the technology organizations, because they're technology organizations, like they're going to be the elite performers. They're going to be the ones that really stand out.
Everyone? No.
What?
Retail. And retail does significantly better. Now, we lay this out in the report. I love your shocked face. This is my favorite. Now, what we found is that for the last decade or so, there's been what has been termed the retail apocalypse. It is unbelievably competitive. Retailers have had to embrace things like A/B testing to really understand what drives consumer behavior.
Right.
So that they know what to offer consumers. They've had unbelievably slim margins, so they have to embrace efficiency, they have to embrace automation. They also have to do things like scaling for things like Black Friday.
Right.
So there is no question about should we go to the cloud? Should we embrace automation? Should we be doing things like A/B testing? They are already there, because if they don't, they have already closed down.
Right. And with Google Cloud, we see eBay doing things like this. So they're using machine learning models and they're using artificial intelligence to really help their customers find exactly what they're looking for much faster, making that a much more efficient transaction, both from the customer perspective and from eBay's perspective.
Yep. And so we caution that very many other industries are probably following suit pretty quickly.
Yeah.
So
that's nice.
Another thing that we found is that heavyweight controls, heavyweight change approval boards only slow you down.
They slow us down.
And as we've mentioned, when you are slowed down, that leads to batching up of work, which leads to instability.
Right. So, a heavyweight process and control over the changes that go in, that's there for stability. It's there to help us and protect us.
We have the best of intentions, but that can lead to unintended consequences. And in 2014, we studied this for the first time, and we found that heavyweight change approvals were negatively correlated with stability. And so this year, we took a more rigorous approach. I wanted to really design this in, and what we find is it negatively predicts speed and stability. For the same reason I talked about before, right? When you batch up changes, you have a larger blast radius. So it causes instability.
Well, but so in my organization, I'm an architect, and I have I can see the entire landscape, and I understand how changes are coming at the system, and I have a better purview to decide whether or not this is a safe change. So how does that slow us down?
So my favorite joke is when I submit code review of 10 lines of code, someone will approve. Well, they will find 10 errors, but when I submit 1,000 lines of code, it looks good. So the only thing that happens is it ends up introducing delay. However, we do have this great section showing what the CAB, change approval board, what the CAB will look like in the continuous delivery paradigm. And what it ends up looking like are strategists and information beacons. And what you can end up doing instead is architecting.
Okay.
And not just being approvers.
Got it.
So there's a lot of good stuff in there.
Oh, that's awesome. All right, so we understand a little bit about elite performers and what slows us down. How do we get better?
There's so much to do here. Okay, this year, I'm so excited. I got a little excited. We have 2 models. So in the past, we've taken a look at performance. I've been talking a little bit about software delivery performance, speed and stability, organizational performance.
Right.
We did that again this year and added some new stuff like we have in the past. We also took a look at productivity. So we have 2 models.
2 different research models.
2 different research models that are predictive. So keep that in mind. I'll show you 2 models. we're going to hustle through.
2 predictive research models. Whoa.
I know.
What is going on here, Nicole?
Okay. I'm going to teach you all how to read a research model. These are my favorite. Okay. Anytime you see a box, this is a construct.
Okay.
So a construct helps us understand what a thing is. I'm going to call it a thing. It's a construct. And it ends up helping us understand how to measure something, how to evaluate something in ways that only measure the thing, don't measure anything else, and that everyone reads pretty much the same way. Now, I said the word thing a bunch there. So let's look at something like monitoring.
Yes.
So monitoring is a box. Monitoring is a construct. So when we measure monitoring in a scientifically, academically rigorous way, I know that it's comprised of a few things. Monitoring across application, across infrastructure, and it's used to make business decisions.
Okay.
When you include monitoring that way, that helps you visualize the entire stack, in order for it to be predictive of improving continuous delivery, it needs to capture all of those things. And if you word the questions in just the right way, that's the monitoring construct. And it measures monitoring, and those questions don't capture anything else. They don't capture loosely coupled architecture, they don't capture trunk-based development, and everyone who reads the survey reads all of those questions about the same way.
Gotcha. So the question is asked in such a way that I know you're asking me about monitoring, and I understand what you mean when you say monitoring, and I know that's not about trunk-based development.
Yep. And there are several questions. There are lots of them. So I make sure that if you misunderstand it, so we ask lots of questions. By the way, I love all of you who took the survey. That's why there are so many questions, because then on the off chance that I made a mistake or the team made a mistake and we wrote a question that wasn't clear, I can catch it when I do my stats foo and we toss it.
Okay, so we've got these boxes.
We've got these boxes.
And then I see a bunch of arrows.
Now we have arrows. Now the arrows are predictive. So this goes beyond just correlation. We have prediction. So when I said monitoring is predictive of continuous delivery, once I know I have the boxes identified, the constructs, I can look at the relationship between and among the constructs. So I know the types of things that are predictive of continuous delivery, that help me with continuous delivery. I know the things that are predictive of SDO, software delivery, and operational performance. Now, occasionally you will also see a line with an arrow with a minus next to it.
Right.
So you'll see
I
that.
see one. Continuous delivery to burnout. So continuous delivery is predictive of burnout.
Of reducing burnout.
That's what the minus is for.
Yes.
Gotcha.
So anytime you see an arrow without the minus, you can read it as drives, impacts, predicts. If it's a minus, it negatively impacts or it reduces.
Okay, gotcha.
So that's how we can read the model. And you will notice that oval, that's our control variables. That's how I found out that industry, like retail, was different.
Okay.
We also see enterprise is different. This year,
Enterprise
for
is
the
different.
first time only, the size of the company.
The size of the company is different or leads to different results.
Leads to different results in a significant way.
Interesting.
So, now that we know how to read it,
All right.
there's lots more in the report.
Let's drill in a little
Let's
bit.
drill into something. Where do we want to start? Ooh.
Cloud. So cloud is a differentiator for elite performance. Okay, now Nicole, you said that when you ask a question, I understand what you mean by the question.
Yeah.
And you're only asking about that
Yep.
thing,
Yep.
that construct. Okay, so cloud.
See, you're making a face though, and I get it because I talk to lots of people. I talk to a lot of developers. I talk to a lot of sysadmins. I talk to lots of executives, and you can ask 5 people what they mean by cloud, and I'm going to get like 13 answers.
Sure.
Because it's the cloud.
Yeah. So what do you mean?
So how do I get around this?
Yeah.
I get around this by asking about how do you define cloud as defined by NIST, National Institute of Standards and Technology.
Okay. So how does NIST define cloud?
5 key capabilities. On-demand self-service.
Wait a minute. Is this public cloud or private cloud?
It doesn't matter. It's how you architect it.
Okay. All right. So you said on-demand self-service was the first one.
On-demand self-service.
All right.
Can't put it behind a ticket that requires human intervention.
Okay. So if I need a resource, let's say a compute instance, I, the developer, can provision that on my own
Yep.
without having to open up a ticket, hand it off to another department, wait for that to be processed and then come back and now I have a VM?
0 points.
Okay. The next one I see here is broad network access.
Yep.
All right, tell me what that means.
Can you access it from lots of different types of devices?
I see. So if I'm on call and I need to restore an incident and I happen to be at dinner, can I do that from my phone?
Yep.
Interesting. Okay.
Resource pooling.
Resource pooling.
I'm sure you know this one.
Yeah,
Right.
of course. So I have the provider, the cloud provider, has a bunch of resources and they pool them up and then I use what I want and then I give it back and whatever. And it's just there for me.
Yeah.
Yeah.
Rapid elasticity, bursting like magic. This is my favorite.
Up, 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 up. That's the beauty of the cloud. We can scale as our customers, we get more and more customers coming in. Our infrastructure just grows. We serve all of those requests. Everyone goes home happy, right?
And down.
Oh, right.
Up and down.
And down.
Yes.
Yes. Elastic. It goes both ways.
Yes.
That's an
Yes.
important thing to remember. I've seen many people that are newer to cloud that are excited about the up capabilities or the scale out capabilities,
Yeah.
and kind of forget that the idea is also to scale it back down.
Yeah.
Yeah. Well,
Which relates to measured service.
right. So we want to measure how much are we actually using the cloud, and we can get way different insights into how we're utilizing a service. And importantly, what my CFO cares about, how much money am I spending on a service?
Yep. And
That's
we
a
only pay for
completely
what we
different-
use.
Yeah.
Absolutely.
Yeah. So this is what defines cloud. So, but listen, cloud's been around for a long time. So basically shouldn't it just be a control? Like obviously everyone's doing cloud.
In theory, right?
Yeah.
The challenge, though, like I said, is that everyone defines it differently. So that's why this research is so important, because when I go talk to organizations, when I go talk to people leading transformations, they're like, but we did the cloud, I'm not getting benefits. Why doesn't it work?
Right.
So we asked, who's in the cloud? And then we asked these 5 questions. Turns out only 29% of respondents who said they're using the cloud actually meet all 5 characteristics of cloud computing. So if you're in an organization that says, we're doing the cloud, it's not working for me, I'm not getting the thing,
Right.
this is the disconnect. So it requires execution. I paid for a membership to like my gym, but I don't have a 5-minute mile yet.
I paid for a membership to the gym also. Yeah.
You have to do the
So-
work. I'm not saying it's necessarily simple. It requires work, it requires automation, it requires like architecting things.
Yeah.
But you got to do the both. You got to do them both.
An investment, it sounds like.
Yep.
So, okay, so clearly there's room to grow with cloud, but how does this line up across?
Like, why do we care?
Elite performers, low performers, like what does that show?
It enables and accelerates this. Elite performers are 24 times more likely to have met all cloud characteristics.
Wow.
Right?
Yeah.
Because it's about enabling, it's about accelerating, it's about speeding things up. It really helps so many things go. Okay, we've got some clear wins here.
Yeah, it's clear that we need to get to the cloud and really think about the cloud as the whole thing, right? So
Yeah.
we have this idea of fast auto scaling, and as we talked about, that's elasticity. So that's scaling up, scaling down, and the important thing there, I think, in addition to fast, is auto scaling. So
Yes.
it doesn't require human intervention or opening up a ticket. Hey, I need to scale up because we're about to have a bunch of customers come in.
Yep, exactly.
Next, we talked about cost visibility.
The cost visibility is really interesting. So we do have a section in the report showing that because of the way the cloud is architected and because of the information it makes available, it brings that visibility back to those who are building systems. Now, when we're on-prem, it's just kind of a black box. And so there is no incentive to change the way that we're engineering our systems. If we want to aggressively make our systems more efficient, why? And we can't. The cloud enables us to do that in terms of compute resources or cycles.
Right, right. Interesting. And then you also mentioned security here as a clear win from cloud. I know a lot of people, as they're just getting into the cloud, and certainly in some industries, there's some hesitance about going to the cloud because of security. So how is security a clear win from the cloud, Nicole?
So there are so many cloud providers that have already gone through so many steps and so many hoops to be a secure system that meets so many compliance regulations, from information security to even physical security, that then you no longer have to worry about. You can allow your engineers and your professionals to focus on building code the right way and not have to worry about securing your system and securing your buildings even.
Right, right. Well, that's great. And of course, Google Cloud has a ton of different services for you that are available to allow your engineers to focus on building out the applications that your customers care about. It turns out your customers don't actually care about the infrastructure on which your applications run. What they care about is that that infrastructure is available. Sure, they care about that, but they don't even care really about the infrastructure. It's about the applications. So Google Cloud offers a number of different resources that allow you to focus exclusively on that application and put some of those infrastructure concerns to the side, or at least decrease your investment in those infrastructure concerns. So we have tools for compute, for machine learning and artificial intelligence, messaging, monitoring, alerting. All of these things are built into the cloud itself. And when we look at the cloud, we see a number of different capabilities that are really awesome. One of them that I'm super excited about right now is this function or feature called Cloud Run. Cloud Run is this idea where we can take serverless agility and use that with our containerized applications. So what does that actually mean? It means that our developers can have a true serverless workflow and serverless approach to the applications that they're building. You take your application, you containerize it, and then you hand it to Cloud Run. That's it. You don't have to worry about your infrastructure at all. Cloud Run will scale up as your users use your service or as your demand requires. Cloud Run will also scale all the way down to 0. And one of my favorite parts about it, and my CFO's, is you only pay for when the requests are actually being processed.
Nice.
Now that's really cool. It's also a great example of something else that we've seen. We're seeing lots of organizations, for example, at the Broad Institute, they're cutting the cost of research by adopting more and more of the cloud features. So maybe they started off with just compute instances, and over time, as they start really looking at the capabilities that Google Cloud provides, they're able to really slash the cost of research. So they go from maybe just a compute instance down to some task splitting, some preemptible VMs, and so forth, all the way through to the point where they're now using algorithms to tune how they're utilizing resources on Google Cloud Platform.
So I love that because it's a great example of aligning incentives. Once you provide the cloud to your developers, they can really tease apart only what they need. They can build their algorithms, their applications to really be super efficient and just use what they need.
Right. The other thing I love about it is how it took an iterative approach, right?
Yep.
Let's get this into the cloud, and now that it's in cloud, we can start thinking about how do we take more advantage of the features that the cloud really has to offer for us.
I love it. And I love it because it's the Broad Institute and they're doing research.
Absolutely. And the other thing that we talk about a lot is shifting left. So what does it mean to shift left, Nicole? Can you talk about that?
Shifting left is integrating features and functions earlier into the tool chain and earlier into the process, because if we find it late in the system, late in the game, it's so hard and it's so expensive. And by expensive, I just mean effort to integrate all those changes. The earlier we can find it, the earlier in the feedback cycle,
right,
the better we can deal with it and the higher the quality is.
Right, and so we've learned about that when it comes to building applications. We all know that fixing a bug in production is much more expensive than fixing a bug during design.
Right. And in the 2018 report, we found that elite performers could find security features in days and fix them in days, where the low performers, it took them weeks to find and then weeks again to remediate them.
Right, so when security is an afterthought, when we think about security when we get into production, that it's already too late, right?
Yeah.
And so when we talk about shifting left on security, we're really talking about taking those security concerns and moving them to the left side of our workflow, or back to the code, the build portion of that workflow. And in fact, using Google Cloud, when you take your application and build it into a container, we have vulnerability scanning that can look at that container and tell you whether or not there are security vulnerabilities, known vulnerabilities, before your container, before your code gets anywhere near production. We can really improve that feedback cycle and get it earlier in the process. And so if there's a vulnerability found, we'll stop you there. And then the other thing that we have is binary authorization. So you've packaged up your application into a container, you're ready to take that container and run it in your GKE cluster or run it on Kubernetes. Well, how do you know that that container that you're about to run is actually the container that you expect? Is it an approved container that you're going to run? And so that's what binary authorization can do for us. It will look at the binaries and say, yes, this is an approved binary, or no, this cannot go to production. And we see this with tremendous success over at Shopify. So every day, 6,000 built container images are deployed securely into Shopify's environment. 6,000 container images. And there are actually over 330,000 images stored in Shopify's container registry.
And I love that because it shows how security can be scalable.
Yes, absolutely. And when we shift it to the left, it makes it all that more scalable.
Yep, exactly. Now, okay, let's dig into a few more. The thing that's important here is to think about a holistic approach to CD, right? Because it is technology, it is tooling.
Yes.
It's also process, right? So when we take a look here, we can see how all of these things, clear change process, disaster recovery testing, continuous delivery, and this automation really drives our speed, stability, and availability. One thing that's important here is we think about useful, integrated, easy-to-use tools. It helps make CI/CD accessible. Now, on a personal note, I love this because some of this reaches all the way back to my dissertation and my postdoc.
Nice. Well, when you think about the integrated experience, look, I'm a developer. I want to stay in the same context throughout my day. And it doesn't matter if I'm writing code for the first time or getting that code pushed off to production. And so with things like Cloud Build, which is integrated with GitHub, you can actually get those signals all without leaving the UI and the experience that you're used to. So within GitHub itself, when I submit a change, Cloud Build can pick up that change and automatically build it. I don't have to switch context and think, okay, I've submitted a change, now I need to go build the thing. The thing gets built, and I get feedback directly in that same interface that tells me, how did that build go? Were there vulnerabilities in that build? And so forth.
Now, what we found is only 40% of our respondents are doing disaster recovery testing annually.
Annually?
Annually.
Annually.
Disaster recovery testing is pretty important because it helps us understand the state of our production systems and what's necessary and important to keep them running. So I love the idea of these DIRT events, disaster recovery testing. And before I ever came to Google, I kept hearing stories about it. So much so that we included this quote from Kripa Krishnan in the book.
Yeah, it's a great quote. For DIRT-style events to be successful, an organization first needs to accept system and process failures as a means of learning. Things will go wrong. When they do, the focus needs to be on fixing the error instead of reprimanding an individual or team for a failure of complex systems. I love that. The whole focus on learning is something that really brings joy to my heart.
I know, it's great. And the thing that I love about this is that it focuses not just on improving the technology, but also the team surrounding it and the processes surrounding it, because there's so much opportunity to make things better here.
Yes.
Now, I'm excited about this because in the past, Google's Project Aristotle has studied this culture of psychological safety and how it's so important for teams to be able to do this. Mm-hmm. Now, there was a little bit of side commentary out in the industry saying, of course, Google would find this because Google is this environment where you have this amazing culture and you don't have to worry about things, and they give you lunch and everyone passes this amazingly difficult bar for interview, and there's no way that this could hold in the rest of the world. And so many thanks to the Project Aristotle team. They shared their measurement instrument with the DORA research team this year. And so we studied this externally, and this is what we found. We found that this same culture of openness and shared purpose also contributes to software development and delivery. So it's a different outcome, but similar.
Right.
In the rest of the world, these same findings hold true.
I see, and culture is more than just free lunch.
Absolutely.
Right? So let's talk about some of the culture that we do have at Google that I think can apply in your organization as well. So the first is that we let data guide us. We use data to make decisions. That's super important. Next, we have collaboration and a shared fate. So when you think about DevOps, how do we align development and operations? We're collaborating together. We're sharing a fate, or we're sharing responsibilities. Next, there's transparency. So we talked about this a lot when we talked about cloud. Can you get transparency into what are the resources costing you, how are those resources performing, and so forth. That transparency is important within our systems, but when I say systems, I mean our systems. Not just our systems, but our systems, right? So think about CPU, of course, but finances and customer satisfaction.
Yep.
Transparency is important across all of that. And then lastly, and every organization can take on this as part of their culture, a blameless postmortem culture, where when incidents happen, and they will happen, what we do is we take those incidents and those failures as opportunities to learn. And we do that through a good blameless postmortem culture.
Okay, now let's dig into the second research model. As I said before, anytime there's a box, that's a construct. Anytime there's an arrow, you can read it as prediction. If that arrow has a minus, it means it reduces. So this year we took a look at productivity. Now, this is a special kind of productivity. It's not writing lines of code. It's not the number of bugs that you kill. It's when you hit that special flow, when you feel like you've done a lot of good complex work for the day. Now, productivity is important because it helps us feel like we've accomplished work. It helps us do a lot of good work for the day. Now, what types of things do we feel like contribute to this? We just talked about useful, easy to use tools. This is great because that's highly correlated to the CI/CD work that we just talked about. Also search, also things like reducing technical debt.
Right.
We're gonna dig into a couple of these.
Yeah. So
I just talked about search.
Yeah, let's start with search. So I see here that we have a 1.73 times productivity improvement when there's good internal search. What do you mean by internal search?
So internal search encompasses a lot of things. It's like, can I search my internal code base? Do I have a good internal set of documentation? Do I have knowledge bases? Do I have wikis? Do I feel like I can ask my colleagues? It encompasses a few things.
Gotcha. And then external search might be things like Stack Overflow or YouTube videos for that matter. Places where developers and operators go to learn more about the technology that they're using or the tools that they're using, maybe the bug that they've encountered. They use external search for that.
One note that's important to point out here is that external search is going to be better if you're using open source tools because there will be a broad community from which you can pull.
Right, for sure. And who isn't using open source?
I will say that low performers are the highest users of a fully proprietary tool set. But read into it more. We don't have time to get into it now.
Yeah, definitely.
Teaser. Okay. Also, technical debt drives reductions in productivity. So how can we reduce technical debt? This is super important, and we see this show up so many places. One thing that's interesting, because we all know that refactoring helps with technical debt. Martin Fowler wrote a great book on it. But what else can we do in terms of smart investments in tooling? Code maintainability. How can we maintain our code, help our code bases be searchable so that we don't contribute to tough dependencies? Loosely coupled architecture helps with this, as well as monitoring. One thing that's interesting you'll probably note, these things also show up in our other research model. Smart investments in flexible, extensible, viewable systems help reduce technical debt.
So this can help with performance and productivity.
Absolutely.
Great.
Now, what else? Why do we care? I mean, I want to be productive. The other reason this is important is that when I have a good day at work, when I feel like I hit that great information, that great flow, and I can get a lot done, I can solve complex problems, that lets me leave work at work. I can shut my head off, I can shut my brain off, I can go home, and it helps reduce burnout.
Oh, that's great.
Yeah. So, next up, quickly, what works and what doesn't. So many people ask me, how can we scale my DevOps transformation?
For sure. I mean, we've been talking about the word DevOps for a decade now.
I know.
And I've seen organizations where a small pocket of the organization will adopt some of these practices and ideas, and they do so to great success. But how do they get that to go across the entire organization? How do you actually scale it out?
So we asked all of our respondents what they're doing, what we're seeing, and then we did an additional analysis, another cluster analysis, particularly among our high and elite performers, which was over 40% of our population, so you can choose what works best for you. Here's what we see. Elite teams favor structural solutions that build community, things like communities of practice, grassroots efforts, and a couple proof of concepts. The reasons these are good is because they build community so they will be robust to things like reorgs or product changes.
Okay, so if these are the things that are good, what are the things that we should avoid?
These things are not great. Training centers, centers of excellence are a big bang approach. Now, there were a couple notable training centers that have gotten some press that are pretty good. The challenge with some of these and centers of excellence are that it centers expertise in one place. It essentially creates another silo. They also take extensive resources. It's really, really tough to figure out how to get that to spread throughout an organization and keep it sustainable.
Right.
It can work, but you've got to know what you're in for.
Well, and I would suspect that a training center works best when the learners that come into that training center come in with a problem of their own to solve, as opposed to come in to consume some predefined curriculum.
Yep. Now, we do see it show up in a handful of our high performers, but only about 9%. Now, I will mention Big Bang approach doesn't show up among our highest performers really at all. We do see it among our low performers, which does make sense. If you need a hard reset, you can do it, but you need to know that this needs to be a multi-year approach and a multi-year model.
Right.
Okay, some of our key takeaways. The industry continues to improve, particularly among our highest performers.
All right, well, that's great. So if the industry continues to improve, and we talked earlier about DevOps has crossed the chasm, can we just stop talking about DevOps? Is it now just the way?
It could be, and honestly, so many companies I work with ask me that. I would say choose the word that resonates for you in your organization. If it's DevOps, if it's Agile, if it's digital transformation, if it's just transformation, use whatever's going to work for you.
And that's going to help you with both your commercial and your non-commercial goals.
Yep, absolutely. Cloud continues to be a differentiator for the elite performers, but remember, you have to do it right.
Right, so make those investments in those 5 key areas that define what does it mean to actually be using the cloud.
Yep. Productivity can drive performance and work-life balance and reduce burnout.
Which is super important.
For sure.
And also the bottom-up or grassroots, along with communities of practice, work well for scaling out your DevOps transformation.
Yep. Now, remember, download the report for so many more findings and details. You can find that at cloud.google.com/DevOps.
That's the 2019 Accelerate State of DevOps report. All right, well, thank you so much for tuning in today. Please visit Cloud OnAir for more content from Google Cloud experts. Bye-bye.
Thanks.